Hello dear, so this is our second case for Atwood machine. So you will see here that there is a mass M1 which is located on the table, and you have mass M2 which is hanging. Okay, so for our first case, M1 is frictionless, so that means that mu is equal to 0. So when M1 is frictionless, therefore your F here is 0. Okay, therefore there's a tension here, okay, across the ropes, and this is your W2, and of course there is acceleration towards M2. So simply, since there is no frictional force across M1, our acceleration according to Newton's second law is F net divided by M. Okay, and our F net is simply our W2. Okay, so your M2G divided by M1 plus M2. Okay, so to find the tension for M1, since there is no frictional force, T is simply equal to M1A. This is our equation for finding the T. And the equation for finding T across M2 is simply equal to M2G minus A. Okay? So what about if our M1 is having a friction? So this is our M1 and is connected. Okay, here in this case, mu is not equal to 0. So that means there is a frictional force between M1 and the table. Okay, so you will see here that this is our acceleration. And of course, there is a tension here, and this is your W2. Okay, so in this case, we can say that your A equals F net divided by M. And your A equals F net is simply your W2 minus your frictional force. Okay, divided by M1 plus M2. So in this case, our A now is simply equal to M2G minus mu times M1G. Okay, divided by M1 plus M2. So this is how we find for acceleration. So in like manner, to find for the net force across M1, okay, M1 net force across M1, then F net equals M1A. So our F net is simply your T minus the frictional force is simply equal to M1A. Therefore, our tension is simply equal to F plus M1A. And therefore, we can say that the tension is simply equal to mu times M1G plus M1A. Okay, so this is our tension across M1. So in like manner, to find the tension across M2 is the same. T is simply equal to M2G minus A. Okay, so this is our different equations that we will apply. Okay.